Process states. After completing this lecture, you should be able to define process states. In a multitasking operating system, each CPU or CPU core can be working on one process at a single point in time. As a process runs, its immediate requirements for CPU time and resource allocation change. Processes are assigned a state, which changes as circumstances require. Process states define what process is doing and what is expected to do in near time. Performance of the system depends on a major number of process states. From the birth till death, process has a life cycle going through several states. Broadly, process states are running or runnable, sleeping or waiting, stopped, zombie. Let's dive into each state. Process state running. Kernel-defined state name task running. This is the most healthy state of all. It indicates a process is active and serving its requests. Process is properly getting system resources, especially CPU, to perform its operations. Running process is a process which is being served by CPU currently. It can be identified by state flag R in BS or top commands output, as you will see later in this section in listing processes. The runnable state is when a process has got all the system resources to perform its operation except CPU. This means process is ready to go once CPU is free. Runnable processes are also flagged with state flag R. The process state sleeping. The sleeping process is the one who waits for resources to run. Since it's on waiting stand, it gives up CPU and goes to sleep mode. Once its required resource is free, it gets placed in scheduler queue for CPU to execute. There are three types of sleep modes: interruptible, uninterruptible, and killable. Interruptible sleep mode. The kernel-defined state name task interruptible. In this mode, the process is waiting for some condition, as hardware request, system resource access, or signal. When an event or signal satisfies the condition, the process returns to running. These processes are shown with the state S in BS or top commands output. Uninterruptible sleep mode. Kernel-defined state name task uninterruptible. Process in this sleep mode gets its timeout value before going to sleep. Once the timeout sets off, it awakes, or it wakes when waited upon resources become available for it. It can be identified by state D in outputs. The killable sleep mode. Kernel-defined state name task killable. This sleep mode is identical to the uninterruptible D state, but modified to allow the waiting task to respond to a signal to be killed. This process flag is K, but utilities frequently display killable processes as D state. The process state stopped. The process state stopped has two kernel-defined states and both have the same T flag. First, task stopped, and second, task traced. In kernel-defined state task stopped, the process has been stopped, usually by being signaled by a user or another process. The process can be continued by another signal to return to running. And in kernel-defined state task traced, a process that is being debugged is also temporarily stopped and shares the same T-state flag. The process state zombie. The process state zombie has two kernel-defined states. Exit zombie, with Z state flag, and exit dead with X state flag. In the kernel-defined state, exit zombie, a child process, signals its parent as it exits. All resources except for the process identity are released. It can be identified by state Z in outputs. And in kernel-defined state, exit dead, after the parent receives the exit signal from the child process, the parent cleans up the remaining child process structure and removes the process slot in the process table. The process is now released completely. This state will never be observed in process listing utilities. Note that process can stay in zombie mode if its parent died before it releases child process's slot in the process table. It can be identified with Z in outputs. The complete life cycle of process can be circled as spawn, waiting, runnable, running, stopped, zombie, and last, removed from process table. Thanks for viewing.